Okay, we mentioned about operational definitions. We mentioned that when we have a variable that we want to study, we want to be able to measure it. And an operational definition of a variable allows you to take a variable and measure it. Remember I was talking about height, the variable? Sure, every student in my class, maybe they have different scores. Some of them are taller, some of them are shorter, 67 inches, 64 inches, and so on. Well, what is my operational definition? Maybe my operational definition is height measured in inches. Okay? And the device I would use would be a tape measure that would measure your height in inches. Okay? I would operationalize your height in terms of height in centimeters. I can measure your height in just identifying some people as short and some people as tall. So I say short, 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 tall, tall, short, short, tall, tall, and that could be my operational definition of height too. It may not be as accurate as inches or centimeters, but it nevertheless is a way of measuring height. Okay? So there are usually hundreds of ways to measure a variable. With height, there aren't a whole lot many. Again, like I said, like inches, centimeters, as well as short, short, tall, tall, etc. So there are usually hundreds of ways to do it. And when you do research, you have to decide how you're going to measure that variable. And that's essentially an important aspect of what scientists are doing. Again, not just psychologists, other kinds of scientists as well. So how would you operationally define the following five? Self-esteem, shyness, love, memory loss. And really the hint is there's no one right answer. There are lots of ways to measure these items. So as an exercise, why don't you write down 3 ways of measuring self-esteem, 3 operational definitions of it, 3 operational definitions of shyness, 3 operational definitions of love, and 3 operational definitions of memory loss, just to get you the practice of seeing how they're measured. As an example, I'll just show you with self-esteem. There is a very well-used, well-validated scale called the Rosenberg Self-Esteem Scale. If you wanted to Google that, you can find it. Basically a 10-question questionnaire, asking that, strongly agree, strongly disagree, saying questions like, I am a person of worth at least on an equal basis to others. So if you say, I strongly agree with that thing, that would indicate high self-esteem. And a number of different similar questions, some of them reversed. But if you look it up, Google, Rosenberg Self-Esteem Study for that. But that's not the only way to measure self-esteem. There are other measures of self-esteem. Okay? I might measure someone's self-esteem, a person's self-esteem by their posture. I might look into a classroom, for example, and see people who are sitting up straight, looking forward. I may see some other people who kind of like heads are slanted to the side, maybe looking out into space, and I might conclude those people may have low self-esteem. I could be wrong, but it's still an operational definition of it. I might look at self-esteem by how many friends a person has. Count how many friends a person has. The more friends, the higher the self-esteem. The fewer friends, the lower the self-esteem. Is it a perfect measure? No. No operational definition of a variable is perfect. Anytime you're taking a variable and trying to measure it in some way, you're always going to have some degree of error. But you try to do the best you can, try to make the best operational definitions you can. Okay, another important thing to consider is the setting of your research. You might do your research in an artificial laboratory setting, or you might do it in a real-world natural setting. And each of these settings has some advantages and some disadvantages. If you're running an experiment and you want to control you want to essentially look at a specific relationship between variables, you want to see if manipulating one variable causes changes in the other. Let's say you're testing a new drug and you want to see if this drug has an effect on treating depression. Well, maybe you'd want to minimize all distractions, and you'd want to be able to see the direct effect of this drug without any other outside influence. And in that case, maybe you'd prefer to do a laboratory setting. Advantages of a laboratory is you can control for all those other outside irrelevant events that could affect your study. You can control the environment in a very good way, very clearly in a laboratory. While in a real-world setting, you are unable to control for what happens around you. People can walk in, people can, weather changes, all different kinds of things can happen in a real-world setting that might interfere with what you're trying to find out. So while an artificial laboratory setting is good for controlling what we would call extraneous variables, the unfortunate thing is that the real world doesn't work that way. In other words, is the drug only going to work in your laboratory, or is it going to work when you are trying to get through the day? You want to be able to see if the research you find in the laboratory has some real world applications. So that's why you'd want to also conduct research in the real world natural setting, because then you'd be able to see, well, the drug may work in the laboratory, but does it work on a mom who has to deal with, taking the kids to school and, a stressful job and all that other stuff? In that case, you need to see if the effect works in the real world as well as in the laboratory. So the solution to all of this, which is better laboratory research or real world research, one is not better than the other. They are both important, and if you want to fully examine a topic in psychology, then you should do both artificial laboratory settings as well as natural settings, and see if you're getting similar results in both settings. Fourth step in the scientific method is to draw conclusions. What do these results mean? Okay. And this is where you are starting to use statistics to analyze data. And the statistics, again, are a tool that we use to help us understand the results we got. We're translating it into some values that we can pretty much quickly understand and be able to do something with. Replication is an important thing that you'd want to do when you are conducting research, to do the research again. Again, chemists do this all the time. They'll look at a chemical reaction, they'll observe a chemical reaction, then they'll do it again. They'll do it again, they'll do it again, they'll do it again. See if they're getting the same kind of chemical reaction each time they do it. And replication also comes in psychology, although sometimes it's neglected. But basically what we'd want to be able to see is, if we conduct this research again, will we find the same results? If you found that you did a study and you found certain results, and then you did it 10 times later and couldn't find it again, well, I would put into question the first study you did. Maybe it was just a fluke. And that can sometimes happen. Finally, step 5 of the method is to evaluate. Now you want to evaluate the theory. Now you want to see, does my theory need to be revised? Do I need to, based on my results, does it strengthen my theory? Does it weaken it? Does it force me to modify it in some way? Can I learn more about it? And again, the great thing is that when you get research studies to test a particular theory, what it often does is it allows you to sharpen that theory. It allows you to clarify it, make it even more specific, maybe even more clear, more valid, and as research continues, theories can become more coherent as we learn more about the results from it. So you've done your study, you've connected it to your theory. Now you want to be able to share your results. Why is that important? Well, if you just keep your interesting finding in a file cabinet, nobody is ever going to know about it. So we want to be able to share it with the rest of the world. When you look at the research studies, you're going to find that you will when you do your research study, when you do this, you're going to be able to see the results of other people's work, and you're going to use that for your own research. So you might present it as a paper or a poster at a convention. You might publish it in a professional journal. Either way, you are going to be getting the information out to other professionals, other people who might be interested in it. You might write a book, too. Peer review is an important aspect of journal articles. Journal articles are peer reviewed. Well, let's see this. Certain journals only publish articles that they have reviewed. And a peer review means that at least one to three professionals in that particular field will read your study, read your research manuscript, and essentially decide whether or not it should be published, or perhaps sent back for revision, or perhaps rejected altogether. So peer review, essentially, what that does is it kind of weeds out all of the very poorly done studies. It helps researchers refine their work, maybe do a better study. And that's often done, is that you submit an article, a manuscript for publication. The peer reviewers would say, well, you should have looked at this variable as well. They might give you an opportunity to maybe run another test and resubmit the article later on to address that particular concern. Talk a little bit about meta-analysis. Is this particular statistical procedure that allows you to combine the results of many different studies that all examine a particular topic. Remember I was saying how replication is important. You don't want to do a one and done when it comes to scientific research. You want to be able to do a research study and have it be connected to the past research and lead to future research. You want it to be a continual chain. Do multiple studies, how one study leads to another, and so on. A meta-analysis looks at research on a particular topic where there are multiple studies and basically combines them mathematically. So, for example, you might be interested in looking at the link between self-esteem and depression. Is there a relation between those two? Well, I'm sure that there are some studies that find that that is the case, and there may be others that find that they are not related. Well, what a meta-analysis could do is look at the results of all those findings, essentially mathematically analyze it, and be able to say conclude whether or not maybe that there really is a relationship, or how strong that relationship is. So that's what a meta-analysis does. It's a good way of essentially summarizing a particular body of research, and it's a pretty nifty way of doing that.